Welcome. So in this lesson, we're going to be talking about quadratic inequations, and this corresponds to exercise 3G. So once we're finished going through all these notes, you're going to begin the exercise 3G. Let's begin by reading through some instructions here. It says, to solve a quadratic inequality, you need to first rearrange so that the right-hand side is 0. Sketch the graph of the left-hand side, solving y is equal to 0 to find x-intercepts, and paying attention to the concavity of the graph. Then, finally, we need to state the range of values of x, which gives the correct range of the graph for the given inequality. Now, as always, whenever you're just reading through instructions before diving into actual examples, it seems a bit abstract, so don't stress out if you're kind of reading that and you're like, I have no idea what that even means. Once we go through some examples here, this will make far more sense. All right. The next thing here, this statement that I've written in a blue box is extremely important. Can I get you to highlight it? If you don't have a highlighter, I want you to put asterisks either side of it. That's how important this statement is. Let's give it a read. It says, you must sketch the graph to solve any inequality that is not linear. You must sketch the graph to solve any inequality that is not linear. So in this example, because we're dealing with quadratics, so this would also apply to cubics and so on. But for us, when you're dealing with a quadratic inequation, you need to give it a sketch in order to answer it. So a question that looks like this, so this is a quadratic, and then you've got, less than 0. So you've got an inequality here. So whenever you've got a quadratic inequality, you must give it a sketch. The sketch isn't going to be your answer, but with the sketch, we are able to provide what the answer is. So the sketch itself isn't the answer, but it helps us figure out what the answer is. All right, all seems a bit abstract at the moment, but once we dive into some examples here, everything will make a bit more sense. So here we have x plus 1, x minus 2 is less than 0. Well, looking at our first step here, it says rearrange so that the right-hand side is 0. That's already done for us. We don't have to worry about it. And of course, it doesn't have to be the right-hand side. As long as one of the sides is 0, that's all that matters. So that means we move on to the next sketch step, which says we need to sketch. So I need to sketch this quadratic. To do that, I need to find my x-intercepts. To find my x-intercepts of a quadratic that's factorized in this form, what we're going to use is our null factor theorem, which tells us you take this, you set it equal to 0. You take this, x minus 2, and you set that equal to 0. Then you solve for x. So that means this will be x is equal to negative 1. This means x is going to be equal to 2. So that means I have one over here at negative 1, and I have one over here at 2. Then I can give this a sketch. So it's going to look something like this. Perfect. Your sketch doesn't have to be pretty, and you don't have to get the y-intercept correct. All that matters is that you've got your x-intercepts correct and also the concavity, but we'll talk more about that later. So this is what our graph looks like. Well done. We have our x-intercepts labeled. The next thing that we have to do is come and look at our inequality part here. So it's saying, where is this graph less than 0? Where is this graph less than 0? A bit strange, but let's look at our graph and see if we can figure it out. Well, where it's less than 0, and I want you to shade this in, is in this region right here. This is where the graph is less than 0. So whenever you see a less than 0, what this means graphically is where is it below the x-axis? That's what it means graphically. Where is this below the x-axis? Well, it's below the x-axis between negative 1 and 2. Now we have to write down our x values for which this is true. So that means when my x, and actually let me write this in blue just to remain consistent. When my x is between negative 1 and 2, I'm below the x-axis. Or to say it another way, in other words, I'm less than 0. So that is our answer. So this right here, that's our answer. Our sketch here isn't our answer, but without the sketch, we couldn't have figured this out. So let me put it in a box as well, just so we know it's the answer. So my answer is between negative 1 and 2. I just want to pause here for a second and just kind of appreciate what this is really saying to us. What this is saying is that when I put in x values between negative 1 and 2, I'm going to get out negative y values. So let's see that in action here. So let's say I put in a number between negative 1 and 2. So think of a number between negative 1 and 2. The easiest is probably 0, right? When I let x is equal to 0, what's my output? Well, if I put a 0 here, So if I put a 0 there, it's going to be 0 plus 1. That's just going to be 1 here. And then if I put a 0 there, it's going to be 0 minus 2. It's going to be negative 2. So that means what I'm going to end up with is 1 times negative 2. My answer is going to be negative 2. So do you see when I put in a number between these values here, what I got out was a negative. So when I put 0 in, I got a negative out. And you could keep on doing this. Any number between negative 1 and 2 will give you zeros out, and you can see that there. But as soon as I go outside of these bounds, so let's say I put in a number greater than 2. So let's put in 3. If I let x equals 3, what would I get out? Well, if I put 3 into this, I'm going to get 3 plus 1 is 4. If I put 3 into this, I'm going to get 3 minus 2 is 1. So that means I would get 4 times 1, and guess what? That's equal to 4. Meaning, when I put in, let me do this nicely. When I put 3 in, I got 4 out. And you see how 4 is a positive number. So what we're really keeping our eye on here are these values here, my output values. So when I put in x values between negative 1 and 2, I'm always going to get out y values that are less than 0. And that's why I'm saying that my answer to this is that this is less than 0 when I have x values between negative 1 and 2. As soon as I go outside of these bounds, so for example, when I let x is equal to 3, I'm going to get my y values that aren't less than 0. They're going to be positive. So in that case, they're greater than 0. And in this case, I saw 4. And you could keep on doing this. What if I put in an x value that was less than negative 1? So think of a number less than negative 1. How about negative 2? If I put negative 2 into my x spots here, I would get negative 2 plus 1 is going to be negative 1. And if I put negative 2 into this, I'm going to get negative 2 times negative 2. That's going to be, wait for it, negative 4. Negative 1 times negative 4, a negative and a negative make a positive, it's 4. So do you see when I put in negative 2 here, it's actually going to be the same value there. It's going to give me a positive out. So when I put in an x value that was outside of these bounds, I got a positive out. All right, I probably said that to death now, but hopefully that makes sense of what we're doing here. So these are the boundaries for which I'm getting out outputs that are less than 0. All right, I'll pause here. Hopefully you can just soak all this in, and then in the next part, I'll go through our next example here. I'll see you in that next part.